Okay, folks, we're still working on making some gaskets. Of course, the gaskets aren't really that important because they're strictly for testing and that kind of thing. So I figured while I'm working on the best gasket material to use for the test cylinder, I'm going to start working on our heating and cooling apparatus. Now, we're talking about boiling water at very low temperatures, but it doesn't matter whether the water is at a high temperature or a low temperature. It still remains that once it is at its boiling point, you've got to get 850 to 860 BTUs of water per pound into the water in order for it to actually boil. Now, a pound of water is so many cubic inches, and we've already done the figures on that, and 1 cubic inch of water requires approximately 3.1415 BTUs to actually cause it to boil. Now, that's not a lot of heat, it doesn't sound like, but I did a little bit more research, and according to the figures that I got, it takes 3.41 BTUs to equal 1 watt of electricity, electric power. So what this means is we've got to get a lot of heat into a little bit of water really fast. Really fast. Now, if you take a cubic inch of water and you take one side of that water and you put, let's say the water is 80 degrees, for example, and you've got a heat source that's 100 degrees. Well, it's going to take quite a bit of time at 100 degrees for that 1 cubic inch of water to absorb the extra 20 degrees or BTUs of heat to raise it 20 degrees. Now, if you take that same amount of water and you cut it 16 times, then you have 16 square inches of water at 1/16 of an inch thick. So therefore, that same cubic inch of water spread out over a 16 square inch area should heat up a lot faster or absorb the heat. Now, here's another thing people need to understand. There's a difference between heat and temperature. And temperature is the measurement of how much heat you have in a given volume. So, but heat is heat. Temperature is nothing more than a measurement of that heat per volume. Okay, so what we're trying to do is we've come up with the idea we're going to try to use the natural forces of cohesive and adhesive. Okay, now cohesive is like, for example, when you place a bead of water on a waxed car. You paint a car with a good paint job and you wax it, and you take your finger and you dip it in water and you put it on the car and it'll form a little bead and it kind of rounds up. That's because of the cohesive forces in water are stronger than the adhesive forces between the wax and the water. But now if you get an adhesive force that's stronger than the cohesive force of water, you can actually have water climb uphill. Oh, did I say something? That's like the upside down waterfall, isn't it? Yeah. Okay. What we're trying to do is we need to heat a lot of water really fast, so we want to get it as thin as possible. At the same time, we don't want to cause a resistance in that, okay, 1 cubic inch, okay, that's 1 inch square by 1 inch high. Well, if you had that 30 inch, or say 16 inches high, it would take so much energy to pull that water up that high. But if it was a 1/16 of an inch high and you had a very strong adhesive surface, it would pull itself up just a little bit. But if you got it down to like a 64th or 128th of an inch, it would really pull itself up. That's what we're trying to do. The adhesive forces of aluminum and water, between aluminum and water, is supposed to be fairly decent. So we figure if we can get the distance between two layers of aluminum thin enough, then the aluminum attraction to the water is going to help get it up. And it supposedly helps save us a little energy here. What we're going to do is we're going to take, I'm cutting this off right here because I don't want the glue from this label on here. I got this roll of 10-inch wide, 10-foot long aluminum roof flashing from Home Depot. And with aluminum, it's like glass, except a little bit different. All you need to do is score it lightly, bend it at the score. Whoops, I didn't score it lightly enough, did I? Let's do that again. All right, let's score it 2 or 3 times. Just like sheetrock and glass, or even a brick, make a weak point, and that's where it's going to break. So we do that, and we bend it ever so lightly. Uh-oh, this ain't working, is it? Oh, there we go. There we go. Yeah, that worked good. Okay. Okay, that worked real good. So what we're going to do is we're going to make us a straw that sucks very, very little water and see how much water we can get through it. What we're going to do, the natural adhesive force of aluminum, water's high, but if you get the aluminum, and we're working under negative pressure here, so if we take 2 pieces of aluminum, sandwich them together, and we put a negative pressure, that's going to pull them together so tight, we might not be able to get water flow. So what we're going to do is we're going to cut a piece of aluminum, and we're going to take some coarse grit sandpaper and just rub it down at one time and scratch it. Then we're going to fold it off center to where we've got the scratches to the inside, get it as flat as we can, and we're going to take that little edge and lip it over and seal it. Then we're going to stick it in water and try to suck on it and see if we can get water to come up through it. And I'm pretty sure we will, but we don't want a lot. But we want, again, we're trying to keep the water as thin as possible so it will heat up or absorb heat as quickly as possible. I don't know what else to say other than I just need to turn the camera off and get this thing ready and show you what's going to happen. Because again, I've never done this before, and I've searched the internet and searched the internet, and I can't find anybody that's even tried to do what I'm doing. So everything I do has got to be off the top of my head, and whatever advice some of you great people out there, good thinkers, can give me. That's enough for now. Okay, well, let me finish this and I'll make another clip. .36 grit. Okay, look good. Looking good. Well, folks, the hand benders, hand tongs, they were doing all right, but they weren't exactly what I needed, so I just had to dig out the a little bit better piece of equipment here. So we got our metal down in here. We got to cut a new piece, scratch the lines in it, mark it off. So now we're going to bend it up like yay. Okay, and I'm going to take that off. Uh-oh, I got the wrong one first. Yep. Bring it in here like so. See, hopefully this will work a little better. Alright, put that back in there. Squeeze it down. Oh yeah, that seems to work pretty good. Oh yeah, that worked great. Now I just put it in here and bend the other one over on it. If this works, we're going to be building whatever this length is minus an inch or two, and a whole lot wider. Like I say, with a negative pressure, 2 layers of aluminum should hold themselves together pretty well. I'm just using the scratch marks to get the water as thin as possible so I can heat it up as fast as possible. We'll have to insulate the side out of the sun, but the side in the sun will be open and painted with that that black dip plastic spray stuff that I told you about. Anyway, I'm just trying to see how well this is going to work. So let's give it a shot and see what we can do. Okay. By the way, you can buy this tool right there at either Northern Industrial Tool or Harbor Freight. Either one. They're not very expensive for. If you do a lot of cutting and bending real thin metals, roof flashing and so forth, they're worth their weight in gold, and they don't cost near that much. But if you don't do a whole lot of that type of stuff, then yeah, it'd be like spending gold for it. You know, it's all in how bad you need a tool, how often you use it, as to what it's actually worth to you. Okay. All right. Let me go ahead and get this finished up, and we'll turn this back on and get another clip. Okay folks, this one, it works, but like a lot of things that I do according to theory and taking into consideration theory, I built it too good. This makes the water so thin, the water travels through it fine, but it's so cotton picking thin, I'm scared that, in other words, a cold steam turbine has situation and problems that your regular hot steam turbine doesn't have, and that is we're trying to boil water at a much lower temperature, and I'm afraid with this system it's super easy to build, but the water would be so thin it would heat up and start to boil long before it got to where I needed it. Okay, anyway, stopping thinking about it and drinking a cup of coffee while thinking, I came up with this idea. This another thing I said earlier in another video, that it would be so much easier and cheaper and faster to build your heat transfer units for a cold steam turbine than it would a hot steam. Hot steam's got a lot of pressure, you got to build it strong. Cold steam, all you got to do is worry about the vacuum sucking 2 pieces together. Well, what I've done here is I've corrugated a piece of aluminum, and it's aluminum flashing, and it's so easy to do, it's pathetic. I didn't even measure this one off to build the real thing. I will. All I did was take a slat board hanger that's got a ball on the end of it, if you can see that, so it doesn't cut. If we cut the aluminum and bend it, it has a tendency to crack on you and you get an opening, where if you roll it, it doesn't. And then all I do is just put a straight edge down here like so, and just put some pressure on it and crease it and roll it back and forth, and it rolls the aluminum, it stretches it and rolls it like so. And if you can see, there's the one I just did right there. Does a beautiful job. Okay, come across here. Well, I got room for, oh no I don't either. No, that's perfect right there, because this one's flat and this one's flat, and I put another piece on this side. Now as you put the negative pressure in it, it'll draw the two together, and the corrugations, if they're fastened on the edges, should keep this from spreading out. So it's going to be, I'm pretty sure this one's going to work better than just anything we've tried. So now I'm going to put it in my little hand brake and bend it from here over to here and mark it, seal it, and we'll see how it does. Okay? Okay, I think we got it this time, folks. It's doing real good. I don't know if y'all can see that. I hope so. Let's see. I can't see it that well in the, there you go, in the viewfinder. Okay. But there it is, corrugated, and like so, and it's got the right depths for the holes. Now I'm thinking we need to get, this is going to be the heating side, and of course this is just an experiment to see how well it works and how to make it. I'm thinking some kind of a rig. I make it out of 2x4s or whatever. Lay it down. I need something soft, for example, like this. Paper towels here. There's 4 thicknesses of those painter's rags in a box. But anyway, I'm thinking more on the order of a pizza cutter and round the edges so it doesn't actually cut. You just take the sharp edges of a pizza cutter and just like take a file or a piece of sandpaper and just round the edges so it doesn't actually cut but bend. And spring load the pizza cutter so where you don't actually hold it. That way we can get the exact depth we want each and every time. The heating side needs to be super thin. The cooling side is going to have to be a little bit more open, mainly so that the water can condense and form droplets and run down the sides. Again, the adhesive coefficient of aluminum and water is pretty high, so we don't want to just hang there. So it's going to have to be big enough for the droplets to form and actually run down, get too much weight and run down. So it's going to have to be a little bit deeper than this. In doing this, okay, it actually increases your surface area. I don't know if you can realize that or not, but it does. It actually increases, because you're going up on an angle here and down on an angle there to go the same distance from here to here, so you actually got more. It might not be much. It might be a 1/16 or a 32nd of an inch more, but every square inch or part of a square inch of surface area is vital. It's very important. And again, one more time, I'm trying to make this to where anybody can do it and show professionals that it can be done cheaper than a high pressure steam. Though whether or not it's going to produce the power, I don't know. Like I said, I've never done this before. But anyway, I think this is going to be really great. This is the way we're going to go. And we're just going to have to use a pizza cutter and spring load it on some kind of a mechanism that'll push it back and forth, or we push it, but it's spring, so it has the exact same power or pressure pushing down on the aluminum every time. And that way everything will come out perfect. We're going to have to, we did these strictly by freehand, okay? When we do the final one, it's going to be roughly 34 inches long. That's how long my bender is. It's about 34, well, somewhere in that neighborhood. Anyway, we'll build a section, and the material, the metal, comes 10 inches wide. So we'll actually make it 10.5 inches wide. I'm sorry, 9 3/4 inches wide. So they'll have a 1/4 inch that will bend up on one and a 1/4 inch down on the other one. That way, when we get one done this way, we put it against the other one and bend that over and seal it with silicone or something. And there you go, folks. Piece of cake. All right. I'm not going to show you building the mechanism to hold the pizza cutter, but when I get it done, I'll show it to you in case somebody has an idea and wants to build one. I don't know. We'll see.